So now that we have memorized the parent functions, the library of functions, what we can do now is we can learn some techniques to shift functions around the coordinate plane and to transform them, stretching them, reflecting them, moving them left, right, up, down. And we'll start this conversation with the concept of a horizontal translation. So horizontal and vertical translations are rigid translations. They don't really adjust the shape at all. They just move them rigidly throughout the coordinate plane. So let's start with three functions. F of x equals the square root of x, g of x equals the square root of the quantity x minus 2, and h of x equals the square root of x plus 3. Now, the first thing that we are told to do is identify the parent function. So the parent function is the one from the list of library of functions. So that would be the square root function, right? Square root of x. Now the question is, as we progress, is what does the minus 2 do to the graph, and what does the plus 3 do to the graph? So what we will do is we will take our guide points for f of x, which are 0, 1, and 4, yielding 0, 1, and 2. And of course we know that that graph looks like this. Now that is f. Now the question is how will we graph g and h? So let's start with g. So if we want basically the same points, what we need to do is we need to think through, what is the subtraction of 2 doing? If I want to obtain the same output, I need a larger value, because the very first thing I do to that input is I subtract 2. So if I was inputting 0 into the square root, now I'm going to have to input x equals 2 to take the square root of 0. So we will input 2, and then the square root of 2 minus 2 is 0. Likewise, if we were going to want to take the square root of 1, we now have to put in x equals 3. And that will give us the square root of 3 minus 2, which is the square root of 1, which is 1. And lastly, we took the square root of 4. To get 4, we're going to have to put x equals 6 in. And so if we put in 6, we're going to get the square root of 4, which is 2. So if we plot those points, 2, 0, 3, 1, and 6, 2, there's g. And so you'll notice that what we've done is we've really shifted the graph of f to the right 2 units. Now, let's look at the graph of h. So h, the first thing that we do to our input is add 3. So we're going to have to compensate for our x values by moving to lower values. So if we want to get the output of 0, we're going to have to look at the input, 0, and to get a 0 underneath your square root, we're going to have to use negative 3. So let's try negative 3. The square root of negative 3 plus 3 is 0. Now if we want to put 1 in to the square root, we're going to have to use negative 2 plus 3. So negative 2 plus 3 is 1. Take the square root. And then lastly, if we want to take the square root of 4, we're going to have to use x equals 1. and that will give us the square root of 4, which is 2. So if we have x equals negative 3, we get 0. If x equals negative 2, we get 1. And if x equals 1, we get 2. And so there is the graph of h. This is the graph of f shifted left 3 units. So now let's write g in terms of f. That means instead of writing the square root of x minus 2, what we can do is we can use f as another name for the square root function. So notice that f of x equals the square root of x means that whenever I put in 2f something, out pops the square root of whatever that was. So if we take the square root of x, if we put in x into f, we get out the square root. That is the same thing as if we just wrote the square root there. So put in x, and that function tells you to take the square root of it. So in g, what are we taking the square root of? We're taking the square root of x minus 2. So if we want to put in x minus 2 into our square root function, then we would have the square root of x minus 2. So that means that if we put in x minus 2 into f, we're going to get out the square root of x minus 2. But that is g of x. So in other words, f is just another name for the square root function here. So g of x equals f of x minus 2. Likewise, h of x, well, what are we taking the square root of there? X plus 3. F says take the square root of any input. So I can put in x plus 3 into f, and f says take the square root of that. So notice that if we have f of x minus 2, this was the graph of f shifted right 2 units. And h was the graph of f shifted left 3 units. So here we have the rule for horizontal translations. So translation just means shift. So if h is a positive number, then if we add h to x before we apply our parent function, then what we're going to do is we're going to move left h units. Likewise, if we have a subtraction, we're going to move right h units. And in both of these instances, h is occurring before the parent function, and that's why it's a horizontal translation. It is affecting the inputs, so it's affecting the x values, so it's a movement x.